Okay, we're moving on to exercise 3.5, and we're looking at multiplying and adding complex numbers and what they look like on the Argand diagram. We start out by looking at the multiplication function on a complex number and its effect on the result on the Argand diagram. So let's say we have a complex number, x plus yi, and we want to multiply the complex number by some real number. You've got three cases. The first case is if that number is greater than 1. Okay, so here's an example. If we've got our complex number 2 plus 3i and we want to multiply it by 3, what effect does that have on the Argand diagram? If we do it just using general algebra, 3 times 2 plus 3i gives you 6 plus 9i, which is marked here. Now, what effect does it have? Basically, what happens is when you multiply it by 3, you stretch the original complex number by a factor of 3 along the same line. Okay, so this is your resultant, and these are 3 equal parts. Okay. Now, what happens if you're multiplying it by a number that's like a fraction less than 1? So, sorry, just to summarize, multiplying by 3 has the effect of stretching the complex number by a factor of 3 along the same line, starting always at the origin. Now, what happens if you're multiplying it by a fraction? So let's say you were multiplying by a half, and here this is our original complex number, and this is when we multiply it by a half. Now, the multiplying by half has the effect of contracting or squashing it by a factor of 2, and again starting at that position up to there. What about if you multiply it by a negative number? Okay, so here's your example here. You have z equal to 4 plus 6i, and we're going to multiply that by minus 1, and it ends up at minus 4 minus 6i. Now, what effect does it have? It has the effect of mirroring the complex number in the origin. So what you do is you draw a straight line to the origin and you continue on the same distance on the far side, and you end up at minus 4 minus 6i. Here's another example. If you have the complex number 2 plus I and you multiply it by minus 3, now the first thing you've got to do is you're going to mirror it in the origin, and then you're going to stretch it by a factor of 3, and you end up out here. So mirror and stretch by a factor of 3 gives you minus 6 minus 3i, and you're there. Multiplying by a negative number has the effect of reflecting the complex number in the origin and then stretching or contracting the complex number. Alright, what about when you add complex numbers? How does that look on the Argand diagram? So let's take the example. We have z1 equal to 2 plus 3i, so that's here, and z2 is equal to 1 minus 2i, that's down there. Now, if we're using algebra, if we add them, we end up with 3 plus I, but how could we show this on the Argand diagram? Well, here's how it goes. You make a parallelogram like this. So if you draw this line here, okay, it's not really working. I'm going to have to do it by hand. Okay, and here. Now I'm just cheating a bit. My answer is here. And you complete the parallelogram, and you end up with 3 plus I. So in other words, just to recap, you draw your two complex numbers that you're adding, draw a line from the origin to each number, and then complete the parallelogram, and then the opposite vertex to the origin is going to be your answer, in this case 3 plus I. This is called the parallelogram law. Multiplying complex numbers. Now, what you'll be seeing mostly is multiplying by I squared, etc. Okay, so if you multiply a complex number by I, it has the effect of rotating it by 90 degrees anti-clockwise. Let's do the algebra on it first. You start out with a complex number, z is equal to 4 plus 6i. Multiply that by I, you get 4i plus 6i squared. I squared is minus 1, so you have minus 1 times 6 is minus 6, and then you have your plus 4i. So if you start out here at 4 plus 6i, you end up here at minus 6 plus 4i. Now, what you've actually done is rotated the complex number by 90 degrees. So if you start out there, you draw another line at 90 degrees to it of the same length, and you're going to end up in the, you're swapping your real and imaginary parts, if you see there, and then changing the sign of the y. Sorry, the imaginary. Okay, so multiplying by I has the effect, to repeat, of rotating the complex number by 90 degrees. Now, if you were to multiply that by I again, you would have a further 90-degree rotation, and you would end up down here, same distance. Okay, now this isn't 100% accurate, but it's approximately. And what that would be minus 4 minus 6i. So in other words, multiplying by I squared has the effect of rotating your complex number by 180 degrees, as here. Again, multiply by I cubed gives it a further rotation of 90 degrees, and you end up out here approximately, now I'm just saying, so that would be 4 minus 6i. So multiplying by I cubed rotates by 270, and then by I to the 4 you're back where you started, so you've got a 360 rotation. Okay, now one final example here, and they're asking you to describe the transformation in each of the following. So we're transforming this line here, Z1, Z2, or comma Z2, onto Z3, Z4. And how could you describe that? Well, the best thing to do is Z1 gets mapped onto Z3. Just continue on that line. Okay. Now, what did you do to Z1 to get to Z3? You basically halved the length of the line from Z1 to the 0, 0 mark. Okay. And what to do to Z2 to get to Z4? You again halved the distance between Z2 and the 0, 0 mark. So what you're actually doing there is you're contracting the line by a factor, dividing it by 2. Okay, so we call this a contraction by half. Now, what about to get from Z1, Z2 over here to Z5, Z6? Now I'll just rub out here. Let's look individually. Okay, so just look here, Z1 to 0, 0. Let's consider that line. Okay, now Z1 ends up on Z5. What did you do to the line? You basically, the distances are the same because you're going down 1, 2, 3, 4, and you're going to cross by 1, 2, and here you're going up 2 and going to cross by 4. So this distance is the same as the distance from Z1 to 0. And basically you've rotated it by 90 degrees. Okay, and again you can show the same is true for Z2. So you could draw a line from Z2 to 0 and then out to here. And again, you'd see that that was a 90-degree rotation. So a rotation clockwise by 90 degrees. All right, I'm only going to get you to do 2 questions out of this exercise. We'll cover it more in the papers. But if you do questions 1 and 2, exercise 3.5, that should cover us. We'll do more in the papers when we get to them. Okay, thank you.